All right, welcome back. I hope you're enjoying the conference so far. Our next speaker is Nikolas Laskaris. He is the head of strategy at Comet. Please join me in welcoming him to the virtual stage.
Thank you, Patricia. Thank you, everybody. It's nice to be here. Okay. So, hi, everybody. Nice to be here with you all. My name is Nikolas Laskaris, and I'm head of strategy at Comet, where we're building tools for machine learning practitioners and teams. I'm very excited to be presenting to you all today. Thank you to the AI4 conference for the opportunity. Today, we're going to be covering 3 lessons from the field in building a machine learning ops strategy for your organization. So for a quick overview of what we're going to cover today, we'll start with a brief overview of MLOps, what it is, why it's being discussed so much across industry, and why seemingly every ML org is beginning to invest in it. We will then dive into important lessons from the field that have less to do with the technical specifications of tools and platforms, which are somewhat abundant online today, and more about how to think about MLOps strategically for your organization. These lessons are widely applicable and will help you approach MLOps in a way that maximizes the likelihood that your ML initiatives actually drive value for your business. So these lessons at a high level will cover first, at what point in the maturation of your ML team does it make sense to start thinking about MLOps? What are some of the signals coming from your model development workflows that MLOps should be considered? Second, once you have reached this point where it makes sense to adopt an MLOps strategy, how should you think about team structure and collaboration between the ML org and other business units? How should you think about tailoring your MLOps platform, which will likely consist of a combination of in-house tooling and vendor products? And finally, how does it make sense to measure the success of an MLOps strategy that you adopt? How do you justify to your various stakeholders that this investment is worth your team's time and effort? So that's in essence what we will be covering today. And without further ado, let's dive in. So as I'm sure many of you have noticed, MLOps has started popping up everywhere. High-profile publishers are writing tutorials, top company engineering blogs are filling up with overviews of their own MLOps initiatives and strategies. And we're even starting to see MLOps-specific job postings popping up on job boards. For many, however, MLOps is and remains a relatively new set of ideas. So at a high level, MLOps is a set of practices and tools designed for teams to reliably and efficiently train, optimize, evaluate, package, deploy, and monitor their machine learning models. Put another way, the process of developing and deploying machine learning models is complex. And in the absence of good tooling and processes for doing it efficiently, we see teams everywhere struggling under the weight of what become highly manual and ad hoc engineering tasks, a lack of lineage and explainability across their workflows, underperforming models, orphan models, which is to say models that never make it out of the lab and into production, and many, many more challenges. MLOps systems can address many of these pain points when implemented well. And while there is lots of information available that details how to build MLOps platforms from a technical perspective, there is much less information available on how to think about MLOps from a strategic perspective. And this is crucial because, as most practitioners know, the field of machine learning is incredibly heterogeneous in terms of the problems being solved, the modeling strategies being applied, and the size and maturity of these ML teams in general. Because of this, it's often very difficult for leaders to know when and how to start building their own MLOps strategy and whether the specific technical specifications being published on these engineering blogs and by industry publications and at conferences like this one will be useful for their own team. And this really brings us to our topic today. So what we're going to cover are useful and generalizable lessons from the field in implementing your own MLOps strategy from ML leaders who've navigated these pain points themselves. These lessons are not industry or team specific. Our aim here again is to provide a useful mental model for thinking about when and how to implement an MLOps strategy in your organization and how to track the success of that strategy over time. So what we're going to dive into first is what appears to be a simple question, but has some nuance to it, which is when to start implementing an MLOps strategy on your team. And to start, I'd like to consider this quote from Chris Braussman, Director of Data Engineering at The RealReal, which is an e-commerce company selling high-end secondhand clothing and accessories that went public 2 years ago. So Chris says, MLOps is needed now more than ever as companies transition from using machine learning in an exploratory way to using it as a core operational software component to deliver value. And this sentiment gets at something important, which has been widely written about, which is the pervasive issue of modeling projects failing to reach production in machine learning teams. Some of this has to do with general ML maturity and organizations knowing where and how to apply ML to drive real business value. But it also speaks to an important trend as these teams evolve, namely that your team's experience of the pain points solved by an MLOps strategy will grow as your team starts to deploy models into production, and those models wind up becoming essential pillars of value generation for your business. But it's not always easy to know how and if your team is experiencing these pain points. Oftentimes, it is not abundantly clear that something is in fact broken or could be done substantially better. Many small teams or teams who are still largely in an experimental R&D phase with their ML projects simply don't experience the pain points that so many are writing about. And this can cause confusion as to what the value would really be in dedicating time and resources to building an MLOps infrastructure to support that team. So again, Chris at The RealReal, whose team consists of more than 25 people working on building and deploying machine learning models and has grown significantly over the last few years, offers some very, very useful heuristics for how you can start to see if your team is in fact ready to start thinking about adopting an MLOps strategy. So just to go through this list and to keep in mind, if your team is experiencing any of these, it might be a good indication that it's time to start thinking about it. So the first is inefficient workflows. Every step in the ML workflow is manual or it's done with custom code, all the way from data extraction and cleaning to model building and even to model deployment. If code is copied, instead of sharing common steps or sort of a common reusable canonical code repo for the various building blocks of the way that ML projects should be done in your team, if there might be a long ramp up time on tooling when ML engineers switch projects, if you're working in more of a federated landscape where each practitioner does their own thing, it can become quite painful to switch data scientists onto different modeling projects. If you're experiencing deployment lags that involve multiple teams with those testing pipelines as you get a production ready model and you move it towards actually going into production, in the absence of good tooling, that can take a very long time and become quite painful for teams. It can take weeks to retrain models if you need to pull something out of production to solve issues with data or concept drift. That process can take a very, very long time. Scaling issues, training is blocked by multi-day data transformations, technical debt, being locked into a simpler model type due to your deployment pipeline. And then finally, lineage and traceability. When deployment breaks, it's not easy to tell where the failure occurred. If any of these pain points, or if many of these pain points, or all of these pain points are pain points that your team is experiencing, these are pretty good rough indications that it will be valuable to start thinking about adopting an MLOps strategy on your team. But once the timing is right, if we're at a place where our team is experiencing some or many of those aforementioned pain points, many questions remain. ML teams come in all shapes and sizes, from data sources to modeling strategies to precisely what taking a model to production looks like, whether that's mission critical real-time prediction models, serving predictions to customers live, or offline batch jobs generating predictions that inform internal business decisions, and so on. As such, what we're going to consider next are some general principles around how to start implementing an MLOps strategy once you've determined it is in fact a good time to do so. So the first lesson concerns team structure, and maybe somewhat expected, but at a certain size, it is very much in your interest to hire someone to manage your MLOps strategy full-time, somebody like an MLOps architect. This is likely going to be someone with more of a traditional DevOps background, with some exposure to machine learning and machine learning workflows, although these latter areas can be addressed through good training programs as part of their onboarding process. Your platform will inevitably become a complex and important product in and of itself. And as such, it's worth having someone dedicated to building and optimizing it all the time. And as a general rule of thumb, again, Chris at The RealReal suggests that it's a good time to start thinking about hiring a full-time MLOps architect once the number of people building models on your team reaches about 10. The second lesson has to do with the internal structure of the communication and the collaboration between your ML team and other stakeholders in your company. And this is a crucial component to get right. So if you're developing an ML org, you're probably thinking about how can you create real value out of machine learning for your business. And a common mistake we see here is that teams essentially give data scientists complete and total autonomy to figure out what to solve. Now, while data scientists certainly know which business problems are feasible to approach with machine learning tools, they might not and likely do not have an idea of which problems are in fact valuable for the business. Conversely, if you go to someone with domain expertise, other business stakeholders, for example, they certainly know which problems are going to drive business value, but do not know how to apply machine learning to solve those. And so, some of these people have the notion that AI can solve everything, which is in fact not the case. So the key is to gather these personas into the same room to identify which problems are both feasible from a machine learning perspective and create ROI for the business. And this ties into an important topic in the development of an MLOps strategy, which is communication and reporting of ML team initiatives outside the core ML team. A common pain point we see in teams is that the data scientists essentially work in a silo from problem identification all the way through to production-ready model, with little to no discourse along the way with business stakeholders and domain experts, whose insight into how these models will drive business value are quite indispensable. So when crafting your MLOps approach, it is imperative that you build into this approach a consistent and transparent reporting structure. So the stakeholders outside the ML org can in fact track modeling progress and the subsequent impact on key outcomes you're all targeting. So an example from industry, Suraj Supravedi, an ML lead on the Ancestry NLP team, has shared a bit about how they've solved this pain point at Ancestry, where they're building models to scan billions of documents to identify new information sources to add to lineage records of individuals using Ancestry's suite of products. They actually track everything live, and they transmit live model updates to live reports that are actually shareable and accessible by anyone who wants to access them across the company. And importantly, this is not limited to the data science team itself. So all stakeholders have real-time dashboards and reports to track the hypotheses being tested, the models being developed, and what the team is working on. And on top of that, they have regular monthly meetings where the ML teams and the business stakeholders meet, present research progress to these business stakeholders, and realign for the next R&D push in line with feedback from these business stakeholders. So we've covered a bit about team structure and reporting. And once you're thinking about setting up the internal tooling and processes that will support the machine learning workflows your team is working on, most teams we speak to mention two values that rise above the rest in terms of what to think about at a high level, which are one, modularity, and two, reusability. So a common pain point for growing ML teams is building each model on vastly different infrastructure, different pipelines for data collection and transformation, training, evaluation, pre-deployment testing, deployment monitoring, and so on. And while you may well be working on different types of models, it's still possible and highly recommended to build reusable modular components that standardize the way that these ML projects are run internally. So again, some areas where Chris from the Real recommends considering building these reusable components, and where the Real does this are data generation, calculating statistics on distributions of data, transforming data to be ready for training, experiment tracking, model evaluation, and deployment. Each of these steps winds up existing as a modular piece of reusable code, which forms the foundation of what will become a canonical ML process. Obviously, there's always going to be room for variability, but when executed well, this enables continuous training practices that will oftentimes lead to pretty dramatic improvements in the time it takes to do an R&D cycle, as well as the durability of your platform writ large. But even upon building great reusable components for your ML platform, it's going to become clear that there are some areas of your platform where there are still pain points, or where it's going to just be expensive for your MLOps architect or your team to manage them moving forward. And so you'll likely be faced with some vendor decisions to make to fill out this internal ML platform. In the market today, there are seemingly infinite tools, ranging from massive end-to-end platforms to highly specific open source modular tools. And it can be incredibly noisy and challenging to parse all of the options and identify what the right choice or choices are for your team. That said, despite all the noise in the space for MLOps tooling, there are still some rules and heuristics that will help you approach the selection process with confidence that you will make the right decisions for your team. Chris at The Real has a useful framework for thinking about vendor purchases, which we're sharing here. So first is just to look for tools that solve specific pain points your team's experiencing. It's easy to get sold a great story about tools that will solve all of the problems under the sun your team is or ever will experience. The problem with this is that these stories almost never correlate to what your team's specific needs are. So before engaging with vendors, make sure you have gathered information from your team about what their pain points truly are, what tasks are manual, where are cycles taking longer than they should, where are the largest opportunities for improvement. This will help you dramatically narrow and focus your tool search. Second is to develop a data-driven evaluation and selection process before engaging with vendors. So as we're dealing with an ML platform set of tools, workflow tools are notoriously difficult to build quantitative value propositions for. The best approach here is oftentimes to create a data-driven evaluation framework, possibly specific features you need to have or specific workflows you need to see addressed by this set of tools that your team can then test and verify during a pilot. This will help to provide you and the whole team clarity when it does in fact come time to make a purchase decision. And finally, to structure POCs to be as organized, thorough, and fast as possible. So while this might seem paradoxical, it is in your interest to run the shortest POCs you possibly can. That's because software pilots have a tendency to become very drawn out, laborious processes where internal priorities can oftentimes keep pushing the evaluation down the to-do list and nothing gets tested well. If this happens, you will be left having spent a month or months half evaluating a tool. And in the end of the pilot, you won't have the robust data you need to make a good decision on whether or not to buy. Conversely, if you can condense this evaluation into a couple of weeks, that's a great target to aim for. It will give you good data in a short amount of time so you can free up resources on your team to focus on other things after just a couple of weeks. One final note here on ML platform building and vendor selection, which again is from Chris at The Real, really has to do with making sure you ensure that your team has flexibility moving forward. As we've already mentioned, the space is evolving rapidly. Best practices are still very much taking shape, and your team is evolving and changing rapidly as well. So to avoid vendor lockup, either by using modular tools or tools that come with built-in mechanisms for easy data transfer, is a highly recommended approach to take to ensure you don't get stuck again in 18 months when your needs and priorities inevitably change. So our final topic today, assuming that we've covered a good way to think about when it's the right time to approach MLOps and then how to start implementing an MLOps strategy, is how to measure the value of an MLOps strategy once it's been applied. One interesting note about measuring value from your MLOps strategy is that it will take different forms at different stages of the model lifecycle due to the need for MLOps platforms to support both experimental and automated workflows. And we're going to cover what that means right now. So if you look at the machine learning development process, and this is a chart from Microsoft, we have the various stages of the pipeline here: data collection, data cleaning, eventually to feature engineering and model training. This process is iterative, right? We can spend weeks, months, or years on this, always looking to improve the business KPIs and model metrics. And what these arrows in the chart show you is that at any point in the development of these models, you can go back to any point before in the pipeline, right? You might completely revisit model requirements. You might need to collect more data. You might need to label more data. Because of these built-in feedback loops, which are innate to these machine learning workflows, experimentation is a necessary component of the model development lifecycle. As such, an interesting question emerges, which is how do you measure the value of a platform built to support non-deterministic experimentation? It can be challenging to do this solely based on desired performance metrics from your model, since you don't always know what you're looking for. You don't necessarily know which strategies and metrics will yield the best results on key business indicators. Instead, what you should be trying to measure at the model development stage is the ability of your MLOps platform to unlock better speed and scale of experimentation. So a good use case here from the field is at Uber, home to one of the world's most well-known internal ML platforms, Michelangelo. They have some useful metrics to track efficacy of these experimental workflows. Compared with not using any platform, it can be useful to look at the marginal impact on things like time to model-ready data set, time to production-ready model, and the total volume of experiments that the team is able to run over a fixed period of time, which essentially can be translated into how many hypotheses has my team been able to test. These indicators will give you a good idea whether your MLOps strategy is making the impact on your team you want it to at the development stage. However, things do start to change once you go into production. And this is because once you have a production-ready model, the steps between finalizing that model and getting that model into production should be bulletproof, reproducible, and ideally as automated as possible. In most cases, this deployment process will consist of something along the lines of testing, packaging, model deployment, potentially with shadow model period, where traffic is gradually transferred to the new model pending validation of expected performance improvements, monitoring, alerting, and then potentially retraining as well. The one area of the deployment pipeline that will be hard to automate will be production monitoring, where data scientists may need to dig into data drift and other production issues to diagnose whether what's happening in production warrants a retraining or not. But aside from that, this should largely be an automated process. So how should one think about measuring value here? And again, using Uber and the Michelangelo team as an example, they have an internal CI/CD system built for continuous model serving and monitoring. Since they rely heavily on models making business critical real-time predictions, this is an essential tool in their ML toolkit. And as you can see, their deployment pipeline consists of many of the elements we covered on the last slide. So in this case, you can really return to a more conventional measure from the DevOps world in terms of measuring success, like engineering hours saved on manual tasks. Comparing where engineers were spending cycles before and after the implementation of this automated model deployment process will give you a good sense of how useful and valuable it is proving to be for your team. So we are coming up on the end of our presentation here. And as we wrap up, I want to just take a quick step back and recap what we've covered in this presentation thus far, as well as offer a few thoughts about where this field is headed in the near future. So while adopting an MLOps strategy is a crucial and challenging set of conditions for any organization, the key lessons and insights from this presentation should prepare you well to tackle this for your team. First, there are clear warning signs and pain points that will emerge to indicate it's time to start investing in MLOps. Building clear lines of communication to business units will set your team up for long-term success, ideally with a dedicated MLOps architect leading the way. When you're building a platform, make sure to build reusable components, to standardize workflows, and be data-driven and efficient with vendor decisions. And when measuring the value of your platform, optimize for speed and scale of experimentation around model development and time savings and automation around model deployment. And all of these lessons will set you on the path to success. And this is an important path to start following, as in the near future, all of these tools, processes, and best practices will become standardized. And then the organizations who adopt them, outsized returns from ML initiatives will lead to clear winners and losers in the market. Your adoption will thus impact your own team's success, your success in attracting top talent, and ultimately the success of your company for years to come. And with that, I'd like to wrap up. Thank you so much for listening, and I'm happy to take any questions.
Wow, Nico, thank you so much. That was amazing. If you could stop sharing your screen, I know this audience wants to give you a huge virtual round of applause. Thank you for sharing with us today. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.